Okay, so now we are going to see the last unit in digital computer system architecture, which is input-output organization. Now, in the previous chapters, you would have seen about processor, how a CPU does the arithmetic operations, and then basics of what is a flip-flop, what is a gate, how actually a digital circuit is made up of, what are the components of a digital circuit. All these things you would have studied in the previous chapters. So the last unit is about the memory and input-output organization. So before going into memory, we will just see input-output organization. Now, input-output is very important for a computer because without giving any input from the user, without any interaction from the user, okay, and uh, if whatever the input has been processed by the system has to communicate it back to the user. So input from the user and output to the user is very important. When that is not there, so what is the point in having a computer system itself? So there is nothing, there is no use of having a computer. So one of the most, apart from your CPU, so these are all important components of a system. You have the CPU, which is the processor, and you have the memory where the data and programs or whatever it is that has to be stored, and finally you also have the input output or the IO. So the one of the main, let's say for example you want to type a C program. Okay, how do you do it? How do you give the program to the system? You will have to use the keyboard for typing. So keyboard is one input device. Okay, similarly after executing your program, so the execution part, once you type the program using an input device, the program gets stored in the internal memory, let's say RAM of your either your laptop or your computer system, whatever it is, it gets stored there. Then the processor, you write a program, so this program is also gets stored in the memory. The data, the input data, and the program gets stored in the internal memory, and the CPU is now directed. When you give the instruction to execute your program, the CPU now takes each and every instruction from your program, and then it divides it into micro instructions. And you must have studied about the memory cycles, instruction cycle, memory cycles, and all that. So they are all micro instructions. So the one that you give in your C program is your macro instruction. So each instruction is then divided into small instructions, which are called as micro instruction. So the micro instruction is executed, and then corresponding they are now converted into binary data, and the uh, different data is now being sent across the various circuits, wherein the so the instruction finally is executed. So this is overall structure. So we are going to see. So as I told you earlier, the input output is very important. So input has to be given to the system, okay, by the user, and after processing, the output has to be displayed in some form. Either the output can go directly to a printer, or the output can be used the terminal. In general, a terminal is consisting of your monitor and your keyboard together is what is called as a terminal. Okay, even though we say terminal means monitor, but terminal actually is a combination of your keyboard and your monitor. So your monitor or your CRT tube is actually your CRT is the earlier version. The earlier version is CRT, cathode ray tube, but nowadays we have the LED monitors. Okay, so LED monitors or your keyboard. So keyboard acts as your input device, and your monitor or your LED screen acts as your output device. So this is very important because the user interaction with the computer is an essential one, and the data from outside the system has to enter into the computer through an input device. So input device is very important. So we are going to see how actually the input device is connected to your what are the circuits, how actually it is connected to your CPU, and how data processes or proceeds from the input device to your CPU and comes back to the output device. Okay, so in this input output organization, we are going to see about what a peripheral device is, and then what is an IO interface, and then asynchronous data transfer, and finally direct memory access. So what is a peripheral device? As I told you earlier, the IO provides an efficient mode of communication between the central system and the outside environment. Okay, so the programs and data must be entered through into the computer memory for processing, and the results obtained from computations must be displayed through either through your screen, as I told you, your LED screen, or to the printer. But the main problem here is the mismatch, the speed mismatch of the IO device and your CPU and memory. So this is the important concept here. This is why there is a huge gap between the CPU, and that is why we need to learn more about this IO organization. It is not because the speed in which the keyboards, because wherever there is user intervention, human the speed of human is very less compared to the speed of a computer, a CPU. Whenever I say computer, it means the processor or the CPU. So the CPU is multi-faceted, and it is very high. It is very fast compared to human speed. So the way in which, even if you take, even if you ask the world's fastest typist, okay, to type the program, even then the CPU, it cannot, he or she cannot match the speed of the CPU. So there is a huge gap. There is a huge mismatch between the speed of the input device and the CPU. As you already know, that the CPU these are all important resources of the computer. So what is an important resource of a computer? Your processor and your memory. Okay, in later semesters, you will be studying another paper which is called as operating system, where you will see in detail about how the CPU and the processor and your memory is very important, and they are all important resources of a system. So we cannot see the system, wherever we talk about system time. Okay, the system time is chargeable. It is money. Okay, so see, let's say you go to a browsing center, and you are using your computer for browsing for about 1 hour or so. He is charging you. What for he is charging? He is not just charging for the electricity, for the internet and all that. He is also charging for the system that you are using, the computer time that is being used. Okay, so like that, the if suppose a company is doing a project outside, okay, a project for its client, then the client will be charged for the number of hours that the system is being used. So the main important, so whenever we say processor time is very important, and the processor time cannot be wasted. Okay, so because of this mismatch in the speed of the input device and the CPU, what will happen is, at some point, because whenever there is some input, whenever the CPU is requesting some input from an input device, so till the input, the whole input is being processed, the processor cannot do any other job, and it has to be idle. Okay, so till such time the full input is being given, the processor has to be idle. So that is why we need to consider some other an alternative for instead of direct the CPU directly involving itself in IO process. We need to have some other thing intermediary, so that the processor time is not wasted. The processor does not remain idle. Okay, and programs, as I told you earlier, programs and data are stored in storage medium. Now the magnetic device and magnetic tape and magnetic disk are also considered as input output device. Okay, because you can store nowadays, in earlier days we had the magnetic tape and the magnetic disk, but now you don't have the magnetic tape and disk, but instead of that you have your hard disk. Okay, you have the hard disk, which is again a magnetic disk. Okay, where you can store the data, and the magnetic disk acts as an IO device, as well as a storage medium. You can store data into a device, And from the stored data, it can also act as an input device. You can store the data in the device, in the disk, and from the disk the data can be transferred. Okay, the data can be fed into the CPU for processing. So the magnetic tape or magnetic disk, or nowadays we use the hard disk, this can be used as a storage medium as well as IO device, input output device also. But the input out, it is not always that the hard disk will be your the speed of the hard disk, since it's an electronic storage, the speed of the hard disk, the magnetic disk is definitely is higher, and it can match the speed of any of your CPU. So the data from and to a disk can be at a faster rate in comparison with other input device like your keyboard and your monitor. Okay, so not every time the IO device is your magnetic tape or a magnetic disk. So most of the times the input device is your keyboard and the output device is your monitor. Okay, so that is why, that is the reason why we need to know more about this IO organization. How exactly the systems have managed this mismatch in the speed, and how exactly IO happens in is in a computer. Okay, and then device, there are most of these devices are under the direct control of the computer. So when they are directly connected, and when they are under the direct control of the computer, we call them as online. Okay, let's say your printer. Okay, your printer will be, see, because those days we had offline devices also, but nowadays most of the things are online, are connected online. Here when I say online, it is not your internet online karayadu. When I say online, when the printer is directly connected to your plugged in, when it is directly plugged into your system, we say that that device is under the direct control of your computer. So it means the output device is online. Okay, similarly your keyboard is always plugged into your computer system. So you have a in a laptop, you have a keyboard which is already plugged into your laptop, so which means that is an online device. So when we say online devices, it means it doesn't mean it is connected through internet and all that. Here online means it is directly connected to your computer. And these devices are designed in such a way that they can read from the memory, and they can also directly write into the memory. Okay, whenever a command from CPU is given. Okay, so these type of devices are called as peripherals. So these IO devices which are connected to the computer are called as peripheral devices. So depending on this IO, okay. Suppose if there are two or more peripherals which are added to your computer, then uh, 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 we say that it is a small computer. When there are huge number of a varied number of IO devices are connected to your system, then we call it as a large computer. So the IO organization of a computer actually determines the size of your system, says whether it's a small system or a large system. Okay. Now, what happens when actually a person types in, when you type in a key on the keyboard? So what happens is, for every key on the keyboard, a unique value, a unique, it's called a standard binary code. So a unique alphanumeric character is attached to each keyboard character. Okay, not necessarily keyboard character, even for a non-keyboard character also. Okay, so non-printable characters. So there are so many non-printable characters in your keyboard, like your backspace, a backspace. Okay, even a backspace is a printable character. So an enter key, a shift key, control key, alt key, all these are non-printable characters. So for all this, you have about uh, uh, a 7-bit code which is called as ASCII code, alphanumeric code which is called as ASCII code. Now what is this ASCII? Expansion for ASCII is American Standard Code of Information Interchange. So ASCII is nothing but a standard. So on those days, nowadays you don't The base is actually ASCII, which contains 128 totally standard codes. But nowadays we don't use just the ASCII alone. We use what is called as a Unicode, okay, which is which is not just 7 bits, which is greater than 7 bits to accommodate all other characters. Nowadays, you have Tamil computing, you can do it in Hindi, you can do it. There are so many other languages. There are so many characters. It is not just the English characters alone. So we use Unicode instead of ASCII. But the base is actually ASCII, whether it is ASCII or Unicode. What actually a computer does is the same. The concept is the same. So now, for the learning purpose, for now we will stick on to the ASCII code. So whenever you press a key in the keyboard, what happens is its equivalent ASCII code, 7-bit code, is transferred to your system. Okay. So these are some of the peripheral devices. These are some of the peripheral devices. So you have the input device, which are keyboard, then optical input devices, you have card reader. Now these are all, in those days, in older days, we had a card reader, paper tape reader, barcode reader. Even now you have the barcode, where when you scan the barcode, the actually input from the barcode is fetched. You can see this barcode reader in all departmental stores. Okay, so the input, the product. What does this barcode contain? The barcode contains the what product it is, okay, and the code for that product. That is what is generated, is stored inside your barcode. So what actually they do is, in a departmental store, when you go and when you buy something, there is a sticker which is placed with a barcode. So they have a barcode scanner, and they will just move the scanner across the barcode, and the scanner will just scan the barcode, and it will take the information. The barcode it will read the barcode, and it will decode it. If the barcode will be converted into some information is stored in the barcode, it will just convert it. What information will be stored? Mostly it will be stored the code for the product. The code for the product will, and all the codes will be actually fed into the system earlier. So actually the code of the product will be given as the input, and actually it will go, and the data will already be stored in the database. So from there the code will be fetched, and the equivalent product description and its price, everything will be fetched from the database. So that is how, that is another input device. So you have the digitizer, you have optical mark reader. Same thing, optical mark reader is also the whenever you have, in entrance examinations, you will be given a optical a waxed sheet, wherein you shade the MCQs for your multiple choice questions. You will just shade the option. So there the optical mark reader is used to capture the shaded answer. Okay. So and then magnetic input device, and then you have screen input devices. You have the touch screen, the light pen, and the mouse. Okay. So apart from this, you have the analog input devices also. Analog input devices, like whenever you have a microprocessor, some other device, wherein, say, let's say you have the what do you call the ECG. Whenever a person is sick and an ECG is taken, so that is an external, it's an analog device. So when the ECG machine is now is connected to a system, computer system, the input from the ECG machine is directed towards the computer. So the analog device takes the readings from the person, and then it's a when you record the ECG wave, it is a continuous input. So whenever the input is continuous, it is called as analog. Okay, and whenever it is discontinuous, so then we call it as digital input. So this analog input is taken from the by the ECG machine, and it then converts it into digital, and the input is fed into a computer. So you have analog input devices and the output devices. Output devices is card puncher, paper tape puncher. These devices were used in olden days. Okay, nowadays we don't have them. And then you have the CRT. CRT is actually your cathode ray tube, or your computer monitor. But nowadays, as I told you, so in those days we used to have a big monitor, Okay, a CRT tube will be there. Uh, Nowadays we don't have CRT. We have the LED monitors which are very sleek in nature. And then you have the printers. The printers can be dot matrix, inkjet, laser, whatever it is. And then a plotter. A plotter is one, again, I'm going back to the same example of ECG, where after the ECG is being processed, you will see the output. You have a plotter which actually draws the graph of the ECG. So that is called as the plotter. And then you have the analog output device, and then your voice can also be an output device, or a voice can also be your input device, because nowadays you have the Alexa, where the Alexa actually takes in, you have even in your mobile phones, it can actually take in your voice input and process. So voice can also be an input device. So these are some of the peripheral devices. Okay. So the next concept is we should know what is input output interface. That we will see in the next video.